In this video we're continuing with our ray diagrams. Okay, in this case, last time we looked at our convex mirror, which has only one ray diagram essentially because of that virtual focus. This time we're going to look at our concave mirror. And as remember, the convention is we draw a small section right in the middle there, using the symbol for concave mirror. Sometimes you'll see those shadings, sometimes you won't see those shadings. And we're going to set our focal point and our 2f, twice the focal point, because it's very useful. Trust me. And we're going to consider the object positioned at 5 different points. Okay, and so this is our object in each case. The first point is outside the focal, twice the focal point. Second point is going to be right on the focal point, that double the focal point, which remember is the radius of curvature. Third will be between the focal point and the radius of curvature. Fourth will be on the focal point, and fifth will be inside. And what I want you to look for while we're doing this, so let's things without that S in them, things to look for. Okay, so there's patterns. That's what I mean by things. Maybe I should have written patterns. Things to look for are the change in, they're all changes I suppose, change in size. So we're looking at the size of the image. I think we need to also consider the location of the image, see if there's any patterns there. To consider magnification, just any other patterns that you might observe. Okay, so let's just shift that up and out of the way. That's sort of our overview. So let's redraw our axes, and we've got our concave mirror in the middle there, and this time, or in our focal points, don't forget f, 2f. That means if that's f and that's 2f, 2f should be roughly twice the distance away from it. My drawings are going to be by necessity rough here, but you'll get the idea. So there's our object. I'm going to draw our rays in green. We should always draw a parallel light ray that runs parallel to the horizontal axes, and because it's a parallel light ray, it'll reflect through the focal point. Okay, I'm not sure I'm keen on this. You explain everything changes thickness depending on how you draw with your what your speed is. I'll get used to it. There's another one we can draw which is quite useful. I'm going to give 3 rays just because it's good to know a few more, I guess. One that goes through the focal point and reflects parallel. Okay, because remember, if it's coming from the focal point, it'll go out and come back parallel. Whereas if it's coming in parallel, like our first ray, it'll go through the focal point. Okay, and the one that we could, that's given us more than enough because we've got 2 rays which cross over, which show where the tip of the head would be, and the bottom, because of light rays would just go out parallel and come back parallel, reflecting straight in there. We know the bottom is always going to be on the same place as that axis. But anyway, that's our image. The other ray that we could have drawn, I'll draw that in a different colour just so you can see it, is our equal angle reflection, where the same distance above and below is to create a triangle. I'll highlight the triangles shortly, but okay, so in theory that angle and that angle are both the same. Okay, so, and you can use, what I was saying before is you can use geometry. You can draw your object inverted directly underneath like a mirror image, and then this triangle here is the same as this triangle underneath. Okay, now in any case, going back to the image that we've drawn, let's just highlight that a little bit clearer. that's where it ended up, and that's about right. The nature of that image, because remember we have to consider the nature, is first thing that's obvious is it's upside down, which means it's inverted. The second really crucial thing is that it's smaller than the original, which means it's diminished. And the final thing which we have to consider is it real or virtual. This is made up of real light rays that are reflected. There's no dotted rays to show where it might have come from. Our image is actually there, so it's real. And what that real means, just to state it more, is that we could project that on a screen. Okay, whereas a virtual one you can't, because there's no light rays to actually make a real image. Okay, a little bit hard to use the definitions, not use the word real in the definition of real for this, but hopefully you get the idea. Real light rays can be projected on a screen. If your eyeballs were seeing a real image, this would have to be right. This image would actually have to be right where your eyeball, the light sensitive part at the back where your retina would be. That's how you would see it, although there would be other interactions with lenses and things in your eyeball. But okay, so that's one. I think this video is getting on a bit, so what I'll do is I'm going to draw all of the remaining 4, in fact we'll draw all 5 of them in the next video on one axis, so you can see this progression of all of these things to look for. But for this video, that's just giving you an idea of how to draw your ray diagrams for your concave mirror.